or potentially ask me questions. So we are going to work on word problems dealing with systems of equations. Remember, if we're at the Desmos website, we can go to Math Tools and Matrix Calculator to get to that matrix calculator. And trust me, that's going to make life a lot easier. We're going to see that these problems that we're about to do could be done using elimination. However, since we know how to use matrices, it makes life a lot less stressful for all of us if we use matrices to solve. If you say, well, I really like elimination, I just want to do it that way, go ahead, be my guest. I'm just trying to make life a little easier for you. So let's take a look at our notes for today. So we got 3 problems that are going to be dealing with word problems. They involve systems of equations. Okay, so here with this, we're going to take it one problem at a time. We're just going to take our time with them, and we'll do good. Again, I do want to show where this is located because this might be a little easier to read off of Schoology. So again, we're in block 2. If I scroll down to week 6, it's the week we're in. And today is Wednesday, so let's go into Wednesday's folder. Under major activities, you will see the blank notes here. So if you want to download the blank notes so it's a little easier to read on your screen than all the way up here at the board, please make sure you do that. The completed notes will come up later today after I finish recording this lesson. So here with this, the school that Lisa goes to is selling tickets to the play. The first day, they sold 12 senior citizen tickets and 14 kid tickets for a total of $208. The school took in $272 on the second day by selling 18 senior citizen tickets and 16 kid tickets. Find the price of both senior citizens and kids tickets. So the very first thing we want to do with this is we want to figure out what our variables are. What are we looking for here? We're going to call them X and Y. So what are we looking for? Price of the tickets. Specifically, I need the senior tickets. So I'm going to say X is for senior citizen tickets and Y is for children's tickets. So I want to define my variables before I do anything else. This way, everybody's clear on what X and Y mean here. Now that we did that, let's look at that first day. First day, we sold 12 senior citizens and 14 kids for this much money. Does anybody have an idea what our equation might be here? Any ideas welcome. 12x, okay. So it's actually going to be plus because we're going with the total, right? Oh, you did. Sorry, it's a little hard to hear with the math. My bad, my bad. Yeah, so plus 14y equals how much money did we make? 208. Oh, we're not going to combine the 2 days yet. We're just looking for the single day sales because both of these numbers were only associated with day 1. We're going to just keep it with the day 1 number. Before I move on to the second equation, any questions on this one? They're really not too bad once you just kind of hit the brakes and just stress about them. We're not going to stress about the solvent or anything like that yet. We're just making our equations. Now the second day, so 18 tickets for senior citizens and 6 kids for 16 kids. What would that equation be? Okay. Good is equal to, how much was our second day in sales? 272. Now, that's right in our equation. We're going to utilize matrices from here. This is set up right for matrices. It's also set up right for elimination, but it seems a lot easier to use matrices instead of multiplying the top by 18, the bottom by -12, right? We could do that. You have the skills to do that. Everybody in this room does. But I want to stress in about, can we set these problems up right? Do we have an understanding of how to change some words to equations? So I don't want you to stress about the solving. So what we're going to do is just turn this into matrices like we were doing yesterday. 12 and 14 in the first row, 18 and 16 in the second row. Well, my -1, then my second matrix will be 208 and 272. So now I can just type this into the matrix calculator and have it solve it for me. Now remember, this is a real world problem, so I do need to write a sentence describing the answer here. So there we go. I go into here, I want a new matrix that was 12, 14, 18, 16, 12, 14. Come on. Thank you. 18 and 16. Then I get my new matrix. Ooh, that's one too many columns, so I reduce that to one column. 208, thank you, and 272, right? Perfect. So now we're going to hit enter. I'm going to do A, hit the A inverse button here, and B. Now remember, before I hit B, our inverse looks all crazy. That's okay. Once we multiply it by B, it works out. Now this one's a little bit interesting because I get 8 for the price of both tickets. So both tickets ended up being the same price. It's a little silly that we're distinguishing between the two, but we didn't know that till we solved it. So that is equal to 8 and 8. So that means that both the kids' ticket and the senior citizen ticket cost $8, right? Both tickets cost $8. Not too bad, right? Once we get this stuff from yesterday was really easy, right? So getting this is what I want to stress about today. Getting our equations. Once we get our equations, we can use matrices to make our life a little easier. This way we're not stressing about 50 different things. We just have to stress about one. Let's look at example 2 here. Example 2 says this: a total of 210 people attend the opening night of a school musical. Student tickets cost $3 each, and non-students cost $7.50. Opening night sales totaled $1,296. How many student tickets were sold and how many non-student tickets were sold? So first, in total, we had 210 people, or wait, sorry, let's look at what our variables are. What should our X and Y be here? What are we looking for? Non-students and students. So, because in the problem, students are mentioned first, I like to make that my X variable. And then while non-students were answered or brought up second, I'm going to make them a Y variable. So X is students and Y is non-students. Now, technically, you can make these variables whatever you wanted. I'm just going with X and Y because that's pretty much the standard we use in math. However, if you wanted to use variables that were more descriptive, like S and N here, that would be perfectly fine for students and non-students. So let's see, in total, there were 210 people. Any ideas how to write that as an equation? In total, we had 210 people. Any thoughts on that? Okay, so we're going to say equal to 210. I like that. What's another way of saying that the total was 210? The 210 is between what two groups? Students and non-students. Do we know how many students showed up? Not right now, that's X, right? Do we know how many non-students showed up? Not right now, that's Y. If it's a total, what operation should go between them? So this is just going to be X plus Y equals 210. I'm not putting coefficients on these. If I put coefficients on these would go a little bit off, but I don't need to put coefficients on them because it's just the total. Now it starts talking about money, right? Students cost $3, non-students cost $7.50. In total, this was our sales. Any ideas on what we might want to do for that money equation? 3X, okay. Plus, okay. Yes, keep it as that decimal, 750 equals 296. Yep. So all I did was make an equation for the total people showing up, then an equation for the money. So here with this, since this is just X and Y, what goes on the top row of my matrix? Good, 1 and 1. Please do not forget about that. Not that I was seeing issues with that with yesterday's work. I just want to emphasize that point. That's going to be 3 and 7.50 to the -1. And now I have my answer matrix, 210 and 1,296. Now it's just a matter of putting this in the calculator. It was $3. That was $7.50. Oh, I put a comma instead of decimal, so it gave me that error. Now we're good. Okay, I had 210 people in total and sold $1,296 worth of tickets. So here we go. I get that I have 62 and 148. So that's telling me I sold 62 student tickets and 148 non-student tickets. And 148. If you notice, those two numbers do add up to 210 if you're paying attention to the very fine details there. which makes sense. I had 210 people show up. So we had 62 students and 148 non-students. If you forget to do it in the calculator, yes. Now, here's the thing, I'm actually not given a quiz on this. We're just doing an activity on Friday to wrap up the whole systems unit. So you actually don't have to worry too much about that. Honestly, I would probably still give you the credit if you put it in the calculator right. So, yes. Yes, when we do this, our answer, X is always the top number, Y is always the bottom number. Because what's essentially happening when we multiply matrices, the rows turn to columns. And so if we go back to this very first example, the 7 goes with the X, right? And then the -1 would go with the Y. So because it's lining up that way, that puts my X's on top, Y's on the bottom. Great question. Now, one thing I want to add to this example here is just talking a little bit about the real world. You know, with the pandemic, movies are just starting to come back into theaters, right? Well, when we talk about box office sales right now, it's a little different because not everybody's going to the theaters, right? Some people are just streaming movies from home because services are still providing that. Equations similar to this is how they can figure out exactly the breakdown of where all the viewing's coming from and all that. So X plus Y equals the total number of viewers. And then they can do, okay, let's call X my streaming people. They can put in how much money they earn per stream plus how much money they earn per movie ticket is equal to the gross income from that weekend. So again, this way, if that data gets a little jumbled up and missorted, we can find it through those equations. So that's just getting you a little bit of context of how we can be figuring out, you know, oh, we don't know, and so many people are streaming. We know so many people are going to the theaters. This is how these movies are making their money. So this is a very simple example with small numbers. If I did an example like that, the numbers be huge because, you know, opening weekend, millions of people are going to see a movie, right? So this number 210 would be in the millions. They're making hundreds of millions in sales, so this number would be huge too, but that's a very similar idea there. Let's look at our final example here. So State Fair is a popular field trip destination. This year, senior class of high school A and senior class at high school B both planned trips. The senior class of high school A rented and filled 9 vans and 16 buses with 530 students. High school B rented 17 vans and 9 buses with 513 students. So how many students are on each van and each bus? So what are we looking for? What are our variables here? What's our unknown here? The bus and vans are our unknowns, so those are going to be my variables, how many people are on them. So again, they talked about vans first, so I'm going to make X vans and Y buses. So really, it's how many people are on the vans, how many people are on the buses. So let's look at high school A. somebody give me an equation for high school A here. Nine vans, 16 buses for a total of 530 students. 9x plus 16y equals 530. That is perfect. Okay, let's try high school B the same way. And thank you for that answer, by the way. 17 vans, 9 buses equals 513. How would we write that? 17x. Thank you very much. And that is absolutely correct as well. So any questions on those equations? We just take our time and read these problems. We're actually going to see some patterns emerge here and how to set them up. So let's set up the matrices. 9, 16, 17, and 9. -1, and that is 530 and 513. So here with this again, I said it before on the first one, we could use elimination to solve this, but this isn't a friendly problem to solve using elimination. I have to multiply the top by, say, 17 and the bottom by -9. That doesn't seem like a very easy way to do this problem. We'll get big numbers in there. Let's just use matrices. Okay, so that was 9 and 16, 17 and 9 on the bottom. And it was 530 students for the first school versus 513 for the second. There we go. And I get 18 and 23. Yes. What class you had into? So let's think about this for a second. Should a bus hold more people than a van? Yeah, a bus is bigger, right? Now, put 18 people in a van, that's a pretty big van, right? And 23 people in a bus, that's a little bit of a small bus, but it makes sense that at least the bus is still bigger than the van, right? That's something we would expect in the real world context of this. So I know the bus will hold the van will hold 18 students and the bus will hold 23. So the vans hold 18 students. And the buses hold 23. And that's it. So unless you have any last second questions on these, I'm going to say, hey, please make sure you're giving this work a try. I'm here to help. I saw a lot of great work yesterday with matrices. So I do expect this to go pretty well with the work too.